Formulas and problem solving. We have two objectives to cover in this video. Number one, solve a formula for a specified variable. And number two, using formulas to solve our problems. So for objective one, we're going to solve a formula for a specified variable. So let's define real quick what we mean by formula. Formula is going to be an equation, and these are going to be given to you. So these are equations that states a known relationship among multiple quantities. Meaning that there's going to be more than one variable in here. So for example, it could be the area of a rectangle, the simple interest formula, perimeter of a triangle, etc. But these are going to be given to you. And then we're just going to solve the problem for one of the variables. So let's try this out. Example 1, it says solve t equals m(n)r for the variable n. So we want to get this n all by itself. So if we look over in the formula they give us over here, it's right here in the middle between the m and the r. And those are all being multiplied together. So you want to run through the same kind of steps we did in the other video, where you want to see if there's fractions we can clear out, are there parentheses we can remove, can we add or subtract to move around the terms to get the variable we want by itself, and then the last step is can we divide to get it by itself. So since this is being multiplied to both that m and the r, we're going to divide mr from both sides. That's going to leave us t over mr on the left. The m's are canceling, the r's are canceling, and just n is left on the right-hand side. And that's what we're after. All we want to do is get the variable they're asking for completely by itself on one side of our equation. Everything else moves to the other side. So here are those steps again to just kind of help guide your solving in this process. So if you have fractions or decimals, start by clearing those out. You can use your LCD for that. Then if you have any parentheses, you're going to use that distributive property to remove them. Combine like terms on each side of your equal sign. Then use that addition property to add or subtract to move things around. And then the very last step is to use that multiplication property of equality to isolate the specified variable all by itself. So let's try this again with example 2. We're going to solve a equals PRT for the variable t. So the variable we want is right over here, the t. Because these are being multiplied, we're going to divide both sides by that PR. And so we get a over PR equals to the variable t. Objective 2. We want to use formulas to solve problems. Example 3. Convert the temperature 5 degrees Celsius to Fahrenheit. Now, if they're asking you to use formulas to solve the problems, they will be giving them to you depending on the problem. So for this one, since we're converting between temperatures, this one would be provided to you. So it is F equals 9 over 5 C plus 32. And that F stands for Fahrenheit and C stands for Celsius. So since they are giving us 5 degrees Celsius, we're going to be plugging in that 5 where the C is and then simplifying this problem. Again, if they need you to use a formula, they will provide most of them. The only ones that might not be provided are things like perimeter and then area for like a square or a rectangle. So for this one, let's plug it in. F equals 9 over 5 times 5 plus 32. Once it's in, we're going to use our order of operations. So we will take care of any parentheses, then our exponents, multiply or divide left to right, and then add or subtract left to right. So this counts as a multiplication here between 9/5 and 5. So 9/5 times 5, 5 divided by 5 is going to actually cancel that off for us. So we are left with 9 plus 32. Then we are going to add, and we get our Fahrenheit temperature of 41 degrees. So 5 degrees Celsius would be equivalent to 41 degrees. And you can even mark it with the little degrees and the F for Fahrenheit. Example 4. A flower bed is in the shape of a triangle with one side twice the length of the shortest side, and the third side is 30 feet more than the length of the shortest side. Find the dimensions if the perimeter is 102 feet. I'm personally a fan of sketching things out. So as soon as I heard in here that there's a triangle, let's make one. So we've got like a short side, a slightly longer side, and the longest side. Now, if I highlight so it makes it a little clearer to see, we have that one side is twice the length of the shortest side. So that means one of our sides is going to be just our variable because we don't know how short the shortest side is. And then the highlighting in blue here, one side is twice the length of the shortest. Twice means 2 times. And then our shortest side is x. So that means our side is 2x. And then we have the third side is 30 feet more than the length of the shortest side. So 30 more than means plus, and then our short side is x. So this side is 30 plus x. You'll notice patterns when you are solving problems like this, that where they relate everything back to one side. So whatever the side is that they're relating it all back to, that side would be just your variable. So again, x is our shortest side. That first side they mention is 2x, and then our longest side here, or our third side, is 30 plus x. Now that we at least know what all of our sides are, they did give us one other piece of information, and that is that our perimeter is 102 feet. There isn't a formula for this because perimeter tells us that we are going to add up all of our sides. So the term perimeter means add all sides. And we're going to set that then equal to 102. So if we add our sides, we've got x, we've got 2x, and we have 30 plus x. And we're going to set that equal to 102. That's our total for our perimeter. And now we have an equation we can solve. So we are going to start by seeing if there's any fractions or decimals to clear, any parentheses to clear. And then next step is we're going to combine like terms. So we have x plus 2x plus x. That's going to give us 4x plus 30 on the left-hand side equals to 102. Doesn't look like there's anything more we can do with combine like terms. So now we're going to add and subtract to move things around. And so we're going to move this 30 to the other side of our equation. And since it's addition, we're going to subtract it from both sides. So 30 minus 30 cancels. And that leaves us with 4x on the left. And on the right, we have 102 minus 30. That gives us 72. So our last step to get x by itself is to divide that 4 off from our variable x. So divide both sides by 4. 72 divided by 4 is 18. Now we're not quite done on this problem, especially with word problems. It's always good once you finish solving to go back and check what they actually were asking for. So this problem asks for the dimensions of all of our sides. So we need to list out the sides for all three sides of our triangle. So one side was just the variable x. So one side is 18 feet. The next side is 2 times x. So if we do 2 times 18, we get 36. So one side of our triangle is 36 feet. And then our last side was 30 plus x. So 30 plus 18. And that last side then is 48 feet. So our final answer is those three dimensions right there.